So this is the last of the new material before our first unit test. We will grade all of our quizzes. We'll go over them next class period. We will test the following. B-dayers, you guys have the test next Wednesday. A-dayers on Tuesday after the 3-day weekend. Okay? And this is more limits that we're finding analytically without the use of our calculator. And these will all involve trig functions. Okay? And these are 3 special ones that we're going to have to know, especially the one on the left. Okay? This limits, I can't find analytically, but I could find using my calculator. And it's just as simple as plugging in, 0.0001 into x and figuring out that sine x over x is approaching the y value of 1. I could do the same thing for these two, and this one is approaching 1, and this one would be approaching 0. There's no analytical way to figure that out. You just kind of do it numerically, but these 3 will help us find trig limits analytically that we're going to be doing, these trig functions, these limits using trig functions, especially this one. This one we need to commit to memory. Yes.
So when I look at problems where in those, it'll be approaching anything other than 0?
It's a good question. What if it approaches anything other than 0? Well, it would just be whatever the function is with that other value plugged in. So if this is the limit as x approaches pi of sine x over x, that would just be the sine of pi over pi. Okay? So this is the only thing you really need to commit to memory is when it's approaching 0. Only for 0. Okay. Now, some things that are going to help us for these, and just really quickly, and you already did problems like this for your homework. If I asked you to find the limit of a trig function, or functions that have trig functions inside of them, the first thing you would do is attempt to plug in the value. You plug in the x value into sine, you get the sine of 0, which is 0. If I wanted to find the limit as x approaches pi over 4 of secant, you plug it in. And you guys did homework problems like this, so this should not be new. Okay. Now, the ones that we're going to deal with are kind of situations like the other analytical limits where we have holes. And we need to find locations of holes, like this one, this guy, these guys. Okay. Some things that will help us with those are the trig identity reminders. Remember that cosecant can be written as 1 over sine. We'll go back to those problems. Secant is 1 over cosine. Cotangent can be written as 1 over tangent or cosine over sine. Tangent can be written as sine over cosine. We should remember that sine squared plus cosine squared is equal to 1. Now I'm going to let you in on a little trick. If you know this one, and you know these guys, you know all the trig identities that you had to memorize in pre-calc. Okay? You can find all of the other ones that you probably forgot, that I forget, by manipulating that sine squared plus cosine squared is equal to 1. Let me show you how. If I took the left and the right side and divided it by sine squared, let's see what I get. I'd have to divide sine squared by sine squared. That would be 1. Cosine squared divided by sine squared is cotangent squared. 1 over sine squared would be cosecant squared. There's another trig identity that you had to learn. If instead dividing by sine squared, I divided by cosine squared, let's see what happens. Sine over cosine would give you tangent. This would be tangent squared. Cosine over cosine is 1. 1 over cosine is secant squared. Okay? And then, of course, with all of these, you can manipulate these by adding and subtracting whatever you want to move things to other sides. So, in particular, cosine squared, if I subtract sine squared from both sides, I would figure out that cosine squared is 1 minus sine squared. Okay, but not 1 plus sine squared. Other things that will help us for these problems is to understand the commutative property of multiplication. If you have A times B times 1 over C, well, you can rewrite that in any order that you want, multiplying any of the two things that you want together. So example is A over C times B, or you could have AB over C, or A times B over C. And if you have fractions that have multiplication, you can split it up. This will also be helpful. If I have A times B over C times D, I can literally write this as A over 1 times B over 1 times 1 over C times 1 over D. If I multiplied these four things together, I'd get A times B divided by C times D. Okay? Okay. Last thing we need to know before we go over, and this is the reminder of those simple limit properties at the end of the video. If you want to find the limits of two functions being multiplied together, it's as simple as just the limits of the first function times the limits of the second function. I will show you why that's really not necessary if you just use your intuition. The limit as x approaches some value of some constant is the limit of that constant as x approaches c times the limits of the function. Has everybody turned their quiz in as of now? No? Okay, that's fine. Moving forward. Okay. Tough trig limits. We need to be prepared to use the one that we've committed to memory to help us. Be prepared to use the limit as x approaches 0 of sine x over x, which is equal to 1. Because we'd be able to figure out this limit. What do we think the limit as x approaches 0 of 3 sine x over x is? Somebody raise a hand and guess. Mr. Kavanaugh. 3 is correct. And to confirm that answer, watch what I can do. I can rewrite this as 3 times sine x over x. And since it's a product, I can split it up into the limits of two things. Limit as x approaches 0 of 3 times the limit as x approaches 0 of sine x over x. What is this? This is just 3. What is this? You know this now. That's 1, giving you your answer of 3. Simple enough, right? I just kind of used, my multiplication properties, and I split up the limits, and I'm good. Let's do another one. Limit as t approaches 0 of root t cubed plus 9 times the sine of t times 1 over t. First thing to realize is that this is multiplication. Since this is multiplication inside the parentheses, and this is going to be multiplication outside, actually the parentheses are there just to kind of confuse you. They don't even need to be there because you're not distributing anything. You'd only distribute if you have addition. So instead, you can eliminate these and just replace it with a bunch of dots. And once you do that, you can then move things around so that you have a sine t over t. And now, why do we want these sine t over t's? Well, having the limit as t approaches 0, I can't plug in 0 and get a defined value. I'm going to have that t in a denominator. I need to get rid of that t in the denominator to be able to figure out what this limit is. The only way I can get rid of this variable in the denominator is by putting it with a sign, and then all of a sudden we have the limit as t approaches 0 of sine t over t, which is 1, and that eliminates it. Okay, so what I'm going to do is just rewrite this. And I'll say, okay, well, why don't I just move the t underneath the sine t, and then why don't I take the limits of the left piece and multiply by the limit of the piece on the right. I know what this is. This is just 1. I know what this is. I can plug in 0 in for t. And this will just be the square root of 9, which is also 3. Getting my answer for this situation is 3. Not all answers are going to be 3. Just like not all of your quiz answers are going to be dealing with 1/4 in the future. But if you did well in the quiz, you should have had a lot of 1/4. Don't worry about it. I'll post the answers and you'll be able to see. A lot of people didn't do well on it. Don't worry. There's going to be a curve. What? I think there was like 3. Could have been 4. All right. I'll put the answers up at the end of the class period. Now, really quick. What you will not have to do is this step. I consider this to be a little bit unnecessary of a step. You can just go straight from here to here and then know that this limit is 1 and this limit is 3. And then you can go straight to your answer 3. But it's this limit property that allows you to do that. Okay? Moving on. If I have tangent x over x, I can't plug in 0 because I'd get 0 over 0. I need to get that x in the denominator with a sign so that I know the limit as that approaches 0, I'd be able to plug in 0 after I got rid of that x, because sine x over x is 1. So what would I do? Well, I'd probably rewrite tangent to start with like that. And maybe that x I'd write as times 1 over x, just to get everything on the same level. That way I don't have fractions over fractions. I don't like fractions over fractions. They're confusing. Then I can move things around so that I have what I want. I want to get rid of this x, so I'm going to put it with sine. And then I'll show you that next step, but this is the unnecessary step that you won't have to do on your homework or on quizzes or anything. You'd write it out as this times this. You know this is 1. I'd be able to plug in 0. The cosine of 0 is 1, so this is times 1 over 1. And that gives you your answer of 1. You'd have to do pretty much the same thing here. You know this is 1, and this would be times 1 over 1, giving you your answer of 1. Questions so far? Okay. Moving right along. This is our kind of first instance of using sine squared. It's important to note that sine squared in that situation is the same as the quantity of sine x being squared. This is just shorthand to write that out without parentheses. What I would do is write this as sine x times sine x. And then if I wanted to, I could have sine x times 1 over x. split up the fractions, make it a bunch of parts. Then I could move the 1 over x to underneath one of the sine x's. Have the other one separate. We have two different functions. We could take the limit of each one. The limit of this first one is 1. For the second one, I would have to plug in 0. Sine of 0 is 0. So this would be 0. Which gives me the answer of 0. Okay? It's all just kind of manipulation, moving things around to get what you want. Why don't you guys try this one? Check your answers with a neighbor once you get it. Tan x over x secant x. Goal is to create a sine x over x so that you can eliminate this x, because that x is the problem. Oh, bless you. Once you have it as different fractions, you can move things in the fractions around as much as you want. And move pieces. Yep, that's it. Yep. Secant is this in the denominator, same as cosine. Yep. Perfect. All right, we should get an answer of 1. I split it up. I rewrote things. I found out that cosines would be able to cancel. The cosine and tangent and the secant would cancel. And then you can move the sine x to be over the x. Boom, you get your answer of 1. Okay? Good. If we can handle that, we're good to go. You ever see a 1 minus cosine squared? Turn it into a sine squared. You could probably see that one of those signs is going to cancel, and the other sign would go with the x, and this answer is also 1. And now this one, actually, that was on the top of our notes, we actually can do analytically. You can't really simplify it just by looking at it and moving things around because you have addition. But you can multiply by the reciprocal here. not the reciprocal, the conjugate. Giving you 1 minus cosine squared over x times 1 plus cos squared. This turns into sine squared. One of these signs will go with that x. You have sine x over x times the other sign would go over the 1 plus cos squared. That's not cos squared, that's just 1 plus cosine. Okay. This is 1. Plug in 0 here, you'd get 0 over 2. This is why that's 0. Okay? All right. Moving right along. Trig functions with a constant times the variable. So the sine of 3x over x. This is different from 3 sine of x that we had earlier. Okay? We need a different technique to be able to figure out this limit. Once we figure out this technique, maybe we'll be able to figure out a quicker way to deal with it. Okay? So I don't know what the sine of 3x over x is going to approach. So what I'm going to do is kind of treat this like one of the problems where we have like the sine of 3x is equal to 1/2. What did I say you had to do to help you solve that equation, sine of 3x equals 1/2? Not necessarily take the 3 out, but we replace, right, with a different variable. So I make it like the sine of y. Well, I'm going to do that. I'm going to say, all right, let's replace 3x with a u. I'm going to say u is going to be equal to 3x. Well, it's going to help me if I know what x is equal to as well. X will be equal to 1/3 u, or u over 3. Kind of flip-flopping the variable that's solved for. Watch what I can do. I can say, okay, this is going to be the limit of, now, instead of x, I'll put 1/3 u, as 1/3 u approaches 0, of the sine of u divided by 1/3 u. All right. Just whenever I saw 3x, I replace it with u. Whenever I saw x, I replace it with 1/3 u. All right, well, I can kind of split this up. Now, this is important. If 1/3 u is approaching 0, u is also going to be approaching 0. And then I'm going to have it's going to be 1 over 1/3. So 1 over 1/3 is the same as 3 times sine u over u. Well, what's this limit? 3, just like the first problem we did. This is just 3. Okay. I'm going to show you a different one. Looks a little more complicated. You get the limit as x approaches 0 of 4 sine of 2x over 5x. Here we go. I'm going to say, all right, replace 2x with u, which means replace x with 1/2 u. This becomes the limits as u approaches 0. It's really 1/2 u, but I'm just going to say it's u because it's the same. 4 sine u over 5 times 1/2 u. Well, that's 4 over 5/2. Which is the same as 8 over 5 times sine u over u. What's my answer? This is 1. This is just 8/5. Okay, so that's the technique. Now let's look at the original problems again. We had the sine of 3x over x. That answer was 3. We had 4 sine 2x over 5x. That answer was 8/5. The technique works, but can you think of a shortcut? Mr. Not Hislop. Houston. Houston. Yep, take that number, just multiply it by the other number, or just kind of pull it out. Now, this is not correct math. You can't just pull things out of trig functions, but in this situation, it works. 4 times 2 is 8. 8 divided by 5 is our answer. If you look at the top one, well, just kind of pull the 3 out. You got sine x over x times 3. That's 3. Does that make sense? What do you think this one's going to be? Ends up being 2/3. This is another one that it's not going to be great. You'll have that one for homework. We'll go over it. I'll show you all the steps. This one is going to be a homework problem. I'm going to give you a hint to solve it right now so that you're ready for it and you can actually attempt it. The key is not only will you first start by writing this is sine over cosine, but you want to use a common denominator up here. Okay, which means this should be cos x over cos x, and then go from there. All right? That's it. I feel like I went too fast, and I might have.